Good morning, dear students. Welcome to Vidya Setu, the YouTube channel of our school. Today, we are going to study a new chapter of physics, which is human eye and the colorful world. In this chapter, today we are going to study dispersion of light through a glass prism and about atmospheric refraction. So let's start our class. So students, before starting, we should know what is a glass prism. Glass prism is a transparent object which is made up of glass, and it has two triangular faces and three rectangular faces. So a glass prism look like this. Okay, this is the glass prism. I will also show you the diagram. Student, a glass prism is something which looks like this. So this is the diagram of a glass prism. If we look at the prism from the top, it looks like this, and if we look at it from one side, it looks like this. From the front face, it looks like this. Now, the refraction of light which is passing through a glass prism is different from that in a glass slab, because in case of glass slab, the emergent ray is parallel to the incident ray, but in case of glass prism, it is not parallel. Now students, we will study the refraction of light through a glass prism. So when a ray of light passes through a glass prism, refraction takes two times. When the light ray enters the glass prism and when the light ray leaves the glass prism from the other side. As the refracting surface PQ and QR are not parallel to each other, therefore incident ray and emergent ray are not parallel to each other in case of a glass prism. So students, अब हम पढ़ते हैं कि refraction of light through a glass prism कैसे होता है. So we have one glass prism here PQR and we have kept it on the base QR. Now a ray of light AB is incident on the face PQ. PQ वाले फेस पे एक लाइट रे आ रही है, इंसिडेंट रे. The incident ray is going from air to glass. यहाँ पे देखिए इंसिडेंट रे एयर से ग्लास में एंटर हो रही है, so it will bend towards the normal. This is normal n dash, so it will bend towards the normal, that is b n dash. So ये यहाँ पे slightly bend हो गई है इस तरीके से, and it is going along the direction BC. Now second time the ray of light is going from BC to CD. It means the ray of light is going from glass to air. So it will bend away from the normal CM. ये normal है हमारा M dash इस वाले face पे. So the ray of light going from glass to air will bend away from the normal CM. CM normal जो है उससे away from bend हो रहा है. Okay. So यहाँ पे incident ray AB, then it goes along BC and then it goes along CD. तो ये जो CD है यहाँ पे, this is emergent ray. And as you can see here, incident ray and emergent ray both are not parallel to each other. So when we extend this AB, हम इसको extend करेंगे back में. So the angle between the emergent ray and the incident ray, it is known as the angle of deviation. The angle EOD is known as the angle of deviation. ओके स्टूडेंट, सो आई होप ये आपको समझ में आ गया होगा. यहाँ से ए बी लाइट जो इंसिडेंट रे है ये प्रिज्म में एंटर कर रही है एंड इट इज गोइंग आउट ऑफ द प्रिज्म एज सी डी एमर्जेंट रे. So students, when a ray of light passes through a glass prism, it bends towards the base of the prism. So here we can see this light ray is going and it is bending towards the base of the prism. And the angle between the incident ray and the emergent ray is called angle of deviation. Now we are going to study the dispersion of light through a glass prism. So what is dispersion of light? So student, dispersion of light is the process of splitting of light into seven colors. Okay, this white light is splitting into seven colors when it is passing through a glass prism. So dispersion of light is the splitting of white light into seven colors on passing through a transparent material like a glass prism. And the band of seven colors which is obtained on a screen, it is known as the spectrum of white light. Okay, students. So in this spectrum, the colors are arranged in the form of Vibgyor, starting from the below and going upwards. So Vibgyor is violet, indigo, blue, green, yellow, orange, red. Students, white light is a mixture of seven colors, and the dispersion of white light takes place because the colors of white light travel at a different speed through glass prism. The amount of bending depends on the speed of colored light in the glass. Now, since different colors travel at different speed, they are bent by different angles. Now the red color has maximum speed in the glass, so red color is least deviated, and due to this the red color forms the upper part of the spectrum, whereas the violet color has the minimum speed in the glass and the violet color is deviated maximum, so it occurs at the base of the spectrum. So just now we have studied the cause of dispersion. Dispersion of light occurs because the color of white light travel at different speed through glass prism. Red color has maximum speed, so it is least deviated, whereas violet color have minimum speed in glass, so it is deviated maximum. Now students, recombination of spectrum colors can give white light again. If we collect all the seven colors of the spectrum on the side of a glass prism which is kept in reverse position, so all these colors they again combine to form back the white light. स्टूडेंट जो स्पेक्ट्रम है वाइट लाइट का by the dispersion of sunlight, we can also see this in the form of rainbow. The rainbow is a natural spectrum of sunlight formed by the rain drops. Rainbow is an arc of seven colors visible in the sky, which is produced by the dispersion of sunlight by raindrops in the atmosphere. Each raindrop acts as a tiny glass prism, splitting the sunlight into spectrum. As white light enters and leaves these drops, the various colored rays present in the white light are refracted by different amounts, due to which an arc of seven colors is formed in the sky. So students, the raindrops act as small tiny glass prisms and they refract the sunlight passing through them. So we are able to see the rainbow in the sky. Let us now study about the atmospheric refraction. The refraction of light caused by the Earth's atmosphere is known as atmospheric refraction. In our atmosphere, we have air layers having different optical densities. The cooler air layer of atmosphere behave as optically denser, whereas the warmer air layer behave as optically rarer in nature. So in our atmosphere, the air layers are having different optical density, and when the light passes from these air layers with different optical densities, refraction of light takes place. Now there are some natural phenomena which are caused due to atmospheric refraction, like twinkling of stars. Why do twinkling of stars occur? Twinkling of stars occur when the light coming from a star enter the Earth atmosphere. When it enters the Earth atmosphere, it undergoes refraction due to varying optical densities of air at various altitudes. The continuously changing atmosphere refracts the light by different amounts and the stars appear to twinkle at night. ओके, तो जब भी लाइट हमारे अर्थ एटमॉस्फेयर में एंटर करती है, स्टार की लाइट, तो हमारे एटमॉस्फेयर में वेरियस लेयर्स होती हैं जिनकी ऑप्टिकल डेंसिटी डिफरेंट होती है। और क्योंकि हमारा एटमॉस्फेयर कंटिन्यूसली चेंज होता रहता है, सो द लाइट रे ऑफ द star is refracted by different amount by the different layers, and thus the star appear to twinkle. Now next question is why planets do not twinkle. See, planets are quite big in size and they are very closer to the earth. So a planet can be considered a collection of very large number of point sources of light. So हम एक इस तरीके से कंसीडर कर सकते हैं कि हमारा जो प्लैनेट है उसमें बहुत सारे point sources of light है. Okay, so जब dimming effect of in one part of the planet is nullified by the brighter effect in its other part. अब वो पॉइंट सोर्सेज का कलेक्शन है, पॉइंट जो सोर्सेज ऑफ लाइट का कलेक्शन है प्लैनेट. सो जो डिमिंग इफेक्ट होता है एक पार्ट में, इट इज नलिफाइड बाय द, इट इज वी कैन से मेड नेग्लिजिबल, nullified, neutralized by the brighter effect in its other parts. So the overall brightness of planet remains same and they do not appear to twinkle. Now next phenomena is the apparent position of star. Apparent position means the star seems higher in the sky than actually they are. This is also due to atmospheric refraction. So here you can see this star, original position of star is A, but we see that the star is higher at position B. Why this happens? See, when light from the star enters the earth atmosphere, it gets refracted. The air higher up in the sky is rarer, but the air near our earth surface is denser. So as the light from a star comes down, the dense air bend the light more. जितना अर्थ के पास लाइट आती जाती है तो वो और बेंडिंग होती जाती है, and due to this refraction of starlight, the stars appear to be at higher position. So original position थी यहाँ पे, तो अर्थ की जो स्टार की लाइट है जैसे ही अर्थ के एटमॉस्फेयर में आई, उसकी रिफ्रैक्शन स्टार्ट हो गई, बेंडिंग स्टार्ट हो गई, वो हमें यहाँ नजर आता है. बिकॉज वी नो दैट लाइट ट्रेवल इन अ स्ट्रेट लाइन, तो हमें ये लगेगा कि स्टार यहाँ पे है, बट ओरिजिनली वो कहाँ होता है, यहाँ पे. नेक्स्ट, एडवांस सनराइज एंड डिलेड सनसेट. वी कैन सी द सन about 2 minutes before actual sunrise and 2 minutes after actual sunset. This is also due to atmospheric refraction. Now see, when the sun is slightly below the horizon. देखिए बच्चों, यहाँ पे जैसे ही सन, ये हॉरिजन है, इसके नीचे होता है, तो सन की जो लाइट है ये अर्थ के एटमॉस्फेयर में एंटर करती है एंड इट्स कीप ऑन बेंडिंग. ये बेंड होके हमारी आईज में एंटर करती है एंड हमें ये यहाँ से नजर आता है. जब हम इसको पीछे एक्सटेंड करते हैं तो इट गो स्ट्रेट, सो हमें लगता है कि सन यहाँ पे है, बट एक्चुअली सन कहाँ पे होता है, होराइजन के नीचे. व्हेन द सन इज स्लाइटली बिलो द होराइजन, देन द सनलाइट कमिंग फ्रॉम लेस डेंस एयर टू मोर डेंस एयर, क्योंकि यहाँ पे अर्थ के पास, अर्थ का जो एटमॉस्फेयर है सरफेस के पास, उसमें ज्यादा डेंस एयर होगी एज कंपेयर टू द एयर इन द नियर द स्पेस. So वहाँ पे more dense air is refracted downwards. Because of this, the sun appears to be raised above the horizon when actually it is below the horizon. Alright. तो इसी तरीके से जब सनसेट होता है तब भी होराइजन से नीचे होता है सन, बट उसकी जो लाइट होती है वो रिफ्रैक्ट होके हमारी आईज में आती है, हमें लगता है कि सन होराइजन के ऊपर है. तो this is what we have studied today about the dispersion of light and about atmospheric refraction. Thank you for watching this video. See you in the next video.